We're going to take a moment here to look at two special cases. The first is what to do when you have n things available and you want to arrange r of them. Let's say we're going to arrange all of them. If we can tell the difference between each of them, then there would be n factorial ways. That, by the way, is NPN. NPN is the same as n factorial. But what if we can't tell the difference between some of the things being arranged? Or at least in terms of what we're paying attention to, indistinguishable. So remember 3 factorial or 3p3, that is equal to 6. Let's say that we're going to arrange the letters from the word B, and we can't tell the difference between the two E's. Then either I could put the B in front, or I could put it in the middle, or I could put it at the end of the two E's. So we have two places where the two E's are right together, either both at the end or both at the beginning. And then the other case is where the B's are in between. But what if we are distinguishing between them with a red and a purple E? Then over on the side, we're going to see that we could flip the order of the red and the purple E's. That would give us our total of 6 when we have 3 distinct things, and we're going to arrange all 3 of them. 3 factorial is 6. Let me go back for a moment there. Okay. So the idea here is if we cannot distinguish between some of them, what you would do, similar to how I explained going from permutations to combinations, we were dividing out the order. Here, we would do 3 factorial divided by the product of, we had a total of 3 objects. 2 of them we could not tell the difference. Also, we had the B, 1B. So we'd figure out 3 factorial over 2 factorial times 1 factorial. And that gave us the 3 ways to arrange that we saw at first without the coloration, without the E's being distinguishable from each other. Let me scroll back to that again. So they were right here. Okay. So a similar question then would be as follows. Let's say that we want to find out how many ways to arrange the following letters. Took a moment there to try to think of a word that would not typically get used for one of these examples. The typical one is radar. Well, okay, civilization. There are 5, 9, 10, 12 letters in here. C only shows up once. I shows up 4 times. L once. Z once. A once. O once. And N once. So we're looking for 12 factorial because all the 1 factorials are 1, and multiplying them, okay, we're going to have 4 factorial in the denominator, which I could try to bother to do that by hand by writing out 12 on down to 1 and then 4 down to 1 and cancel out the 4 times 3 times 2 times 1. But I'm not going to get that very quickly anyway. So on the calculator, let's see here. Okay, 12 factorial divided by 4 factorial. Oh, typed that wrong. Delete that. There we go. Pretty large number. Let's do one more of those. In the word mattered, we have 8 letters. M shows up once. A shows up once. T shows up twice. E shows up twice. And then R and D both show up once. So again, 1 factorial is 1. Multiplying by the ones down here are just going to leave us with 2 factorial times 2 factorial. And let's see here. I know 5 factorial is 120. 6 factorial is 720. I'm going to, since 2 factorial is 2 times 1, both of these are 2. So 2 times 2 is 4. 4 into 8 is 2. And 7 times 720 is 5,040. So I'm looking for 2 times 5,040, which should be 10,080. Let's check that out. Again, we're not going to really need to worry about putting in the 1 factorials there. So let's see here. Eight factorial. Delete that one. This time we're dividing by 2 factorial and another 2 factorial. We should put in some parentheses here. Oop, not the curly Q braces, but parentheses. There we go. Insert once more. There's our 2 in front of the factorial, and we're multiplying by another 2 factorial. So here we go. Darn it. I got rid of the 2. 2. Math key. Probability submenu. Factorial. 10,080 as predicted. And one more special case here in just a moment. Suppose that we want to arrange 3 things, but this time it's not a linear arrangement like in a row of seats in the classroom. Suppose it's around a table. We know 3 factorial is 6, but I've color-coded these. Hopefully it's showing up. A is in purple, B is in blue, and C is in green. Out of those 6 in a linear arrangement, 3 of these are going to be the same. If I put A here and then B here and then C up here, the reason this is the same is because when A looks to the left of A, that's going to be C, and to the right of A is B. All we've done is rotated, but their arrangement is the same. You can say we've rotated by 120 degrees, and another 120 degree rotation would give us C over here, and now A is here, B is up here. But once again, A looking to the left is going to see C, and A looking to the right is going to see B. So what would be something different? You could have A up here, and then B over here. It's not showing up all that well. Let me put B in black here. Okay. And C in green right here. Now when A is looking to the left, it's going to see B. A looks to the right and sees C. And our 120-degree rotations this is the same as this. And similarly, A, then C up here, and B down here. All three of these are the same as that first one. Because again, A is looking left to see B, A is looking right to see C, A looks left and sees B, A looks right and sees C. In all three of these. It was reversed where they saw on the left and the right in the first set. So that 3 factorial, that's not what we're getting. We're only getting 2, which happens to equal 2 factorial. To illustrate this a little bit further, it may not be the best animation, but give me a moment here. My claim is that if we have 4 things to arrange, but in a circle instead of a line, instead of 4 factorial equaling 24, we're going to have 3 factorial giving us 6. So this animation is probably something that I'm going to wish to redo. What I did was color-coded the seats that they're in. And again, I'm asking the question of who's left of A, who's right of A, who's straight across. And you should see 6 different arrangements of those colors. Anything else, you'd be rotating the people. In this case, by 90 degrees. So instead of 4 factorial equaling 24, we're only going to get 3 factorial or 6 arrangements of 4 things. 4 things available, arrange all 4, but this time it's in a circle. And that's all I've got. I hope this helps.